Okay, our focus today is going to be on proofs and similarity proofs, which work a little bit different than triangle congruency proofs, especially when you're dealing with the sides. Remember that there's three different ways that we really have shown that triangles are similar, and those three ways have been the easiest one is angle angle. The harder ones tend to be side angle side and side side side. Because when you're dealing with sides, you have to show that they're proportional, right? So you have to say that the fractions are the same, and that does get a little bit cumbersome down the road. So we're going to go ahead and start off with the proof here. I'm going to assume that you already pressed pause on the video and that we're going to go ahead and go. I'm going to do the first few proofs quite quickly just because the last proofs do take a while. It's going to be two-sided page. So here we go. Given that mn, sorry, that should be an mn. Go ahead and change that for you real quick. Given that mn over PR is congruent to ON over QR, I want to prove that triangle MNO is similar to triangle PQR. So as always, the first thing we're going to start off with is the givens. This given sounds like, it doesn't sound like much, but oh my goodness, does it actually do a lot for you. MN over PR is equal to ON over QR. Now, what the heck is that saying? That's saying that this fraction, MN over PR, let me go ahead and highlight those so you can see them. MN over PR, when I divide those, it's going to be the exact same thing as ON over QR. ON over QR. That's saying that the ratios are the same. Like if I were to take those two numbers and I got 3, like the green to green and I got 3, then pink to pink is also 3. So I know it sounds like a small little statement, but really what that's saying is that this side, the green side, gave you the same fraction as the pink side. So right with that one statement, they already gave you two sides. And I know this because it was given. As far as the statement, that's all that was given there. But as far as the picture, they also gave me that this angle, angle N, is congruent to angle R. They told me that in the picture. So I'm going to go ahead and write angle N is congruent to angle R. This was also given. And already, look what I have. I have a side and angle aside. I can already say that the triangles are similar. So I'm just going to go ahead and copy this down exactly the way it's written. You don't have to, come up with anything yourself. You're going to say, therefore, triangle MNO is similar to triangle PQR. Now, I would love to say, and this is, of course, by side angle side. I would love to say that all these are going to be that easy. They're not. But, hopefully that made sense, and we can kind of move on from this, okay? All right, so I was able to check off with side angle side because I was able to give those proportions here, okay? We'll show you where the proportions get a little bit rougher. All right, so here I just have this triangle, and they asked me to prove that triangle SUV is similar to triangle TUW. As far as what did they tell me in the problem, they didn't tell me anything in the problem, but in the picture, they did tell me that angle S is congruent to angle W. So I can go ahead and write that right now. I know that angle S is in fact congruent to angle W. How did I know that? They literally just told me that in the picture, so I get to say that this is given. That means I got an angle right here. Now, the hope is always try to go for angle first because that's the easiest one, right? And I'm already halfway there. I already have one of the angles. I hope I can try to go with this one. So now the question is there a way I can figure out another angle? And in this case, there sure is. There is a bow tie, which means bow ties give me vertical angles right there. So I can go ahead and say that angle SUV, sorry, that was a really weird U. Angle SUV is congruent. Now, when I said SUV, I went yellow, green, and then blank. So I better do the same thing over here. I'm going to start at the yellow. That's going to be angle WUT. How did I know that those were congruent? Well, this is true because of vertical angles. And that gives me another angle, and that is enough to say that the triangles are similar. So I get to go ahead and say that triangle SUV is similar to triangle TUW. How did I know that? Well, I knew by angle similarity, and I'm done with that proof as well. So far, the two similarity proofs have been pretty easy. We're going to go over one more that's not too bad either, and then we're going to do the really challenging ones. So if you haven't done so, go ahead and press pause on the video and copy these down. I'm going to assume you already did that, so we're going to go ahead and say, given that AB is parallel to DC, I want to prove that triangle ABE is similar to triangle DCE. Okay. All right. So as always, I'm going to try to use whatever is given. And the first thing I notice is that they told me AB is parallel to DC. Let me go ahead and write that down. I know that AB is parallel to DC. This was given. On my picture, I should draw that these lines are parallel. So let me go ahead and do that right now. I'm going to say that this line is parallel to this line. That does not mean those sides are congruent. In fact, you can clearly see that DC is smaller than AB. So they're not congruent. However, whenever I give you parallel lines, you should be looking for letters, whether those be F's or those are Z's. There's a couple of different ways you can do this. I'm going to go ahead and say that these angles are congruent right here. I see a backwards F. You didn't have to go with this one, but that's the one I'm going to go with. I can call this one angle B. I cannot call this angle C. There's too many angle C's hanging around. So let me go ahead and start off with that. I'm going to say angle B is congruent. And because there's, I don't know like which angle C, I need to give it a name with 3 letters. So I'm going to call this, well, I hate it when that happens. I'm going to call this angle DCE, and that catches that angle right there. So angle B is congruent to angle DCE. Why is that? Well, because I was able to make my backwards F. I can't say because of F's. When you make an F, that is corresponding angles. All right. So that gave me one angle. And honestly, guys, I could do the same thing and get the other F on the other side. But just so that we are practicing different things and you're not, you kind of have all these tools in your belt, instead of doing this F, which you absolutely can, okay, it would be super valid. I'm going to actually go with angle E. I'm going to say angle E for the little triangle. Here's my little triangle. Angle E is congruent to angle E for the big triangle. Of course, angle E is going to be congruent to angle E. It's part of both of my triangles, and I can say that that's true because of reflexive property. I guess for each one of these, I should have been drawing lines, so feel free to kind of complete those lines back in the notes. I'm not going to do it, but it should be separated. So I know that angle E is congruent to angle E. That gives me this angle right here. And remember that I got these angles over here. That's enough. I got 2 angles. I can say that the triangles are similar, which is exactly what I was trying to do. I'm going to say that triangle ABE is similar to triangle DCE. How did I know that? Well, this time, again, it was because of angle-angle similarity. So we finished 3 proofs, and we did that in relatively quick time. These next 2 proofs are not going to be relatively quick. They are going to take a little bit longer because they're going to involve sides. So that's the first part. Let's go ahead and scroll down. This is going to be the last 2 proofs, but like I said, that last one down there, that one is going to be pretty tough. So we're going to go ahead and roll with this, and let's see how this goes, okay? So let's see. Given that ij is equal to 3ln and jk is equal to 3np and ik is equal to 3lp, I need to prove that triangle ijk is similar to triangle lnp. That given is something that we have not seen before. Like something is 3 times another thing. That can be very confusing. But I know that you always start with your givens. And as far as the picture, there's nothing given in the picture. As far as the statement, there's definitely a lot given in that statement. So let me go ahead and write that down. They said that ij is equal to 3ln. They also told me that jk is equal to 3np. And I'm going to run out of space, so I'm just going to write it down here. Ik is equal to 3lp. And all of this is true because it was given. What the heck is going on there? Well, let's go ahead and do this really quick. What I am going to do is I'm going to divide both sides of this by the ln. And I know you're looking at that and you're going, what the heck are you talking about? But let's just see what happens, okay? I'm going to do this on the side so you can see exactly what we're talking about. I said ij ij is equal to 3ln. Remember, ij is this side. ln is this side. So what I'm going to do is I'm going to divide both sides by ln. And I know you're looking at that and going, what the heck? But it'll make more sense once you see it. If I were to divide both sides by ln, then these ln's are going to cancel. And really what I'm left with is ij divided by ln is equal to 3. What is that saying? That's saying when I take this side and I divide it by this side, the answer I get is 3. Is that good? I don't know. It might be good. I just know when I take this side and divide it by this side, the answer I get is 3. Now, if I were to do that again, I'll do it one more time just so you can see. jk equals 3np. jk equals 3np. Same thing, I'm going to divide both sides by np, so that way I can get that 3 by itself. I'm going to divide both sides by np. And again, you're going, what the heck? Why are you doing that? Well, because now I get jk divided by np is equal to 3. What that means is when I take this side and divide it by this side, the answer I get is 3. So we just set up two proportions. This divided by this is 3. This divided by this is 3. I'm setting up my proportions. I'm getting the same answer. That's telling you that this side and this side are proportional to this side with this side because both times I got the answer of 3. And clearly I could do it again for the remaining sides and say that when I take these two sides and divide it, ik, and divide it by lp, guess what's going to happen? I'm going to get 3 again. Okay, so we need to write all that down. I'm going to go ahead and write it down right here. Notice all this work, right? It's kind of like this side work. I divided to get this. I know that ij divided by ln is equal to 3. Why? Because I divided. I know that jk divided by np is equal to 3. Why? Because I divided, right? I divided both sides by np. And if I were to do it one more time, I know that ik divided by lp is going to equal 3. Why? Because I divided. And so I know that all of these things are equal to 3. And this one is called division property of equality, basically saying you divided. Now, I wish that we could say, like, oh, okay, well, we already have it. You notice how they're all equal to 3? Then they're all equal to each other, right? If they're all equal to 3, then they're all equal to each other. So I get to go ahead and say that the ratio of ij divided by ln, that is to say my pink to pink, is the same thing as my jk over np, or yellow to yellow, which is going to be the same thing as my ik over lp, which is my green to green. All my ratios are equal to each other. And I did this by substitution. They're all equal to 3. That means they're all equal to each other. And that's important because now we just said that all the sides are proportional. The first side, the pink side, is proportional to the yellow side, is proportional to the green side. So because they're all proportional, now I can finally say that these triangles are in fact similar. Triangle IJK is in fact similar to triangle LNP. How did I know this? Well, because I got a side. I got a side and I got another side. I show that all those fractions are equal to each other, and I get to say that this is true because of side-side-side similarity. I know, it's very weird the first time you see it, but we are going to see it another time on the next one, and the next one's going to be even a little bit more confusing. But hopefully you understood. Like, hey, we set up an equation, we divided both sides so we can get the same number over and over again. And then that allowed us to say that the sides are proportional. We're going to do something very similar on the next proof, but it will be just a little bit more complicated. But it is the last one, okay? So you definitely need to see something like this. I have no idea why that P is just kind of floating down there. That's kind of like weird. Let me go ahead and try it. Nope, it's not going to work, huh? Nope, Nope, not gonna work. Let me go ahead and just delete that. Hopefully. There we go. I should have said midpoint. So this is our last proof. It is going to take quite a bit of space, so make sure you scrunch it all the way as high as you can. It says given A is the midpoint of BC and D is the midpoint of BE, we need to prove that triangle BDA is similar to triangle BEC. Okay, so as far as the picture is concerned, I don't see anything in my picture. I always start with my given, so let me go ahead and do that right now. I'm going to go ahead and say A is the midpoint of BC, and D is the midpoint of BE. Hey, they're telling me it's a midpoint. I should not say anything about a bisector because it's not a bisector. It is a midpoint. Okay, so make sure when we do this that you don't use the word bisector, you use the word midpoint instead later on down the road. Okay, and I know that that's given. So I know that that A splits this BC perfectly in half. I know that that D splits this BE perfectly in half. Before I go there, though, I'm just gonna go ahead and look and see. Man, I got those embedded triangles. I know that angle B. I'm trying to prove that this triangle is similar to this triangle, and I notice that both of those have an angle B. So let me just get that one out of the way right now. I'm gonna say angle B must be congruent to angle B, and I know that's true because of reflexive property. So already, right off the bat, I already have an angle. Okay, here is where it does become challenging. Remember, they gave us it that A was a midpoint of BC, so I should use that A. What does a midpoint do? A midpoint splits this up so that you get two equal pieces, the piece on the left and the piece on the right. Let me go ahead and write that down. Actually, let me mark it. Because A is the midpoint, I know that segment BA is going to be the exact same thing as segment AC. Let me go ahead and write that. Segment BA is congruent to segment BC. Sorry, not BC, AC, sorry. And that's exactly what I marked, right? I have those two pieces. BA is congruent to AC. That's true. How do I know that? Well, because it was a midpoint. That's what a midpoint does. So I'm going to say definition of a midpoint. If I were to use that exact same reasoning, then I can go ahead and say, here's my segment BE and D is the midpoint. So I'm going to get two equal pieces. Let me go ahead and mark those two equal pieces. That means segment BD is going to be the exact same thing as segment DE. Segment BD needs to be congruent to segment DC. How do I know that? Same thing. This is definition of a midpoint. Now, here is where, unfortunately, proofs, we have to be very, very careful with the way we write these proofs. Okay, let's just spit out some facts. I know that these two segments are going to be equal in distance because they are congruent. Okay, and I know that's a weird statement to say, but we do need to say it. So let me go ahead and write that BA is equal to AC, and so all I'm saying is the number associated. So if this is like 15, then you got to change this from a segment to a number. Okay, that's all this statement is going to be doing. So instead of like a piece of stick, like, oh, now that piece of stick is 4 inches. And if this was 4 inches and we said that these two sticks are equal, then this 4 must be equal to this 4. All this statement is doing is changing it into a different number. And we're going to do that 2 times. Don't worry too much about this statement. Just know it's something that is necessary in order for you to be able to do the next steps. And so let me just give you this one. We're going to say that these two are equal because definition of congruence, that's what congruence means, that they are going to be the exact same length. Again, don't get hung up on that one. I promise you on a quiz or an exam, I will give you that one. You're not going to have to worry about it, okay? So definition of congruence, we just changed those sticks into numbers, all right? The other thing we're going to go ahead and say is, do you see this big length right here? That big length is made up of two pieces. It's made up of this piece and this piece. So I'm going to go ahead and write that segment BC is equal to the two little pieces put together, BA plus AC. And I can say the exact same thing over here. You see this big piece right here? It's equal to these two pieces put together. So I'm going to say segment BE is equal to BD plus DE. So all I'm saying is that big piece is equal to the two pieces to get put together, and we've actually done this quite a bit. This one is segment addition postulate. You actually took a bunch of notes. The two littles equals the big. Segment addition postulate. Now this is really important, and here's where the math really starts becoming in the proof. You see right here, when I said that BC is equal to BA plus AC, okay? I have like three different segments going on right here. What I am going to do is I just said that this AC is the exact same thing as BA. So instead of writing BA plus AC, I know that AC is the exact same thing as BA. So instead of writing AC, I'm going to replace it with BA because they're the same anyways. They're the exact same thing. So instead of writing BA plus AC, I'm going to write BA plus BA. I'm going to write the BA again. BC is equal to BA plus BA. And over here, same thing. You see this DE? I think I made a mistake. Let me go ahead and, yeah, right over here. Sorry. This should have been, instead of DC, that should have been DE. Sorry. BD plus DE. I was wondering, I was like, why is this not working? You see this DE right here? I know DE is the exact same thing as BD. So same thing. I'm going to write BD plus BD instead. BE is equal to BD plus BD. And you're looking at it and you're going, why the heck are you doing that? Oh, you just wait for the next step. It's coming. And I know this is true because all I did was I substituted. We're almost there, guys. I promise you we're almost there. You see how I have that BA plus BA? I have two BAs right there. So I can say that BC is equal to two BAs. And you see these two BDs? Well, that means I have two of them. And so I can say BE is equal to 2BD. Now, at this point, some of you guys are starting to realize, like, oh, I think I know where he's going. This one is going to be by simplifying. All we did was simplify those two things. This part looks very familiar. This part looks just like this part. And this part was when we started dividing so that way we can get our ratios. So that's exactly what we're going to do. We're going to go ahead and divide both sides by BA. And when I do that, I get BC over BA is going to be equal to 2. And I'm going to do the same thing. I'm going to divide both sides by BD. I'm going to get BE over BD is equal to 2. That means when I take my big piece and divide it by my smaller piece, I get 2. When I take my big piece and I divide it by my smaller piece, I get 2, which means I get a side over here and I get a side over here, which means it can say that I'm going to be able to say those triangles are similar because of side angle side. Before I do that, though, remember that this one was division property of equality. And in order to finish these out, now I can finally say that these two sides must be proportional to each other. BC over BA must be equal to BE over BD, just like we finished it out last time. We do need that extra step. How do I know this? I know this through substitution. That gives me the ability to say those two sides are proportional, which means I can finally say I got my SAS, and I can go ahead and finish this out by saying triangle BDA is similar to triangle BEC. How did I know that? Well, I knew this by side angle side. Thank you for sticking it out. I understand that that last one was definitely pretty challenging. There's a lot of stuff going on that one. Hopefully, the first few made sense. On a test or on a quiz, you're going to look at stuff more like the first three, maybe even the possibly this one, but this would be more like a drag and drop where you would have more options. You're definitely not going to get anything that looks like this, but I think it's really important that you see it at least one time so you can kind of see how involved these proofs are once you get up to the higher division math. All right, as always, if you have any questions, please feel free to ask.